On number 11, we get to show off our ability with the quotient rule. So y prime would be the bottom, x plus 1, times the derivative of the top, which is e to the negative x times the derivative of negative x, which would be a negative 1. So that's the bottom times the derivative of the top, less the top, e to the negative x, times the derivative of the bottom, which of course would just be 1. And then we're going to divide that by the bottom squared, x plus 1, quantity squared. Now we need to evaluate this at 1. That is, we need to say, what is this derivative when x equals 1? So that would equal, up top, we've got 2 times e to the negative 1 times a negative 1. So that'll come out of that first term, a negative 2 e to the negative 1. Then it seems to me that we have minus another e to the negative x, or e to the negative 1, excuse me, when we put 1 in for x. And then in the bottom, we've got 1 plus 1, or 2, and 2 squared is 4. So looking at it just a little more, we got negative 2 e to the negative 1 minus 1 more e to the negative 1. Don't we have negative 3 e to the negative 1 over 4? And can't we write that as negative 3 over 4e? And so our answer here is B. I hope you recognize that we're asked to integrate with this problem, that we're asked to integrate f prime x in order to get f of x, because the integral of the derivative takes us back to the function. So in this case, we've got the integral of 2 over x, which is the integral twice x to the minus 1, or 1 over x, which is equal to 2 natural log x plus c. Now we've got a condition that tells us that if we put or if we put radical e in, we're supposed to get 5 out. That is to say, if we put f of radical e in this function, that is 2 natural log radical e, that's supposed to be an e, let's get that right, we're supposed to get 5 out. Well, isn't that like saying the natural log of radical e squared and plus c is equal to 5? Get this guy out of the way and slide this down a little bit. Radical e squared is e, and the natural log of e, or the log base e of e, is like saying 1 plus c, and that equals 5. So c must be 4. Now that we've solved for c, we know our function is 2 natural log of x, not plus c, but plus 4. And if the original problem was to evaluate f of e, we're going to say 2 times the natural log of e. And if we put e in and take the log base e of e, we get 1. And that's going to be 2 times 1 plus 4 equals 6. So I think that answer up the top would have to be D. D is our answer. You might think substitution for number 13, but that would not be correct. What you should be doing is expanding the square. That is, you should say x cubed squared is x to the 6th. Squaring a binomial, x cubed times 1 is x cubed doubled is 2x cubed, and then 1 squared is 1. That's squaring a binomial. So integrating now, won't we get x to the 7th over 7 plus 2x to the 4th over 4 plus x plus c, or 1/7 x to the 7th plus 1/2 x to the fourth plus an x plus a c, it seems that B is the answer. This goes back quite a ways to recognizing the definition, the formal definition of a derivative. And the formal definition of the derivative was the limit as h goes to 0 of f of a plus h minus f of a over h. Now, the a in this case, well, our function is nothing more, nothing less than e to the x. And our a is at 2. So we're saying the derivative equals, for at any a, equals that limit. And so we're talking about finding the derivative of e to the x. And of course, e to the x, its derivative is e to the x. And if we evaluate the derivative at a particular value 2, we're going to get e squared. So the answer here is D. We've got a slope field here. We're told that we've got a condition that it contains the point at 0, 1. So let's put that point in there. And then think about the solution curve, kind of drawing it in, if you will, with the using the slope field as our guide. So that's what our function looks like. And although it has some appearance to cosine, you know, cosine would be cutting through at pi over 2, just a little bit past a half, would be pi over 2. It'd be equal to 0. It can't be A. B would suggest that as our x's got past 1, or on the other side of -1, we'd clearly have a negative answer, and we don't, so it can't be B. This doesn't look like an exponential curve. You know, it would be going up forever. After we got past that point at 0, 1, it would continue to go up, not decrease, so it can't be C. D, if we expect D and we think about it, you know, you can't have values larger than 1 or values smaller than -1, because they would create a negative under the radical sign. And we do have values larger than 1 and smaller than -1 in our curve, so it can't be that. And as we come to the last one and start thinking about it, you know, isn't this what happens with this curve? As x, when x is 0, we get 1 over 1 or 1. When x starts to grow, the denominator starts to grow, the fraction gets smaller and smaller, and the sign of it doesn't matter. It's got this symmetry in the y-axis. It must be E. So E is the answer to number 15.